Section 6.7, our objective today is to use the number I to simplify square roots with negative numbers. Now today we're going to learn about a larger number system than the real numbers. In the real numbers, it is impossible to take the square root of a negative 4 because in the real numbers there's no number that I can square to get a negative 4. But in what is called the imaginary numbers, we have a special number that is the number I. And the number I is special because by definition I squared equals negative 1. Okay, so that allows me now in the imaginary number system to take the square root of a negative number, since the square root of negative 1 is the same thing as the square root of I squared, which gives me just I. So in the imaginary numbers, I can take the square root of negative 4 and I can rewrite that as the square root of negative 1 times 4. But negative 1 is exactly the same thing as I squared. So it's I squared times 4. So the square root of 4 is 2, and the square root of I squared, whoops, is I. Okay? So another example. If I have the square root of negative 3, what I want to do is I want to think of that as negative 1 times 3, but in the imaginary numbers, negative 1 is I squared. Oops, that should be a times. So the square root of I squared is I, so I can take the square root of that, and 3 is not a perfect square, so it stays inside. Example 2. If I have negative 36, well, I think of that as negative 1 times 36, but negative 1 is I squared in the imaginary numbers. Oops. So the square root of I squared is I. The square root of 36 is 6. And we usually write that with the I behind it. So 6I is negative 30, the answer, because 6I squared is 6I times 6I, which is 36I squared, which is 36 times negative 1, which is negative 36. So in the imaginary numbers, the number I square to get negative 36 is 6I. Okay? And 6I is what we call a pure imaginary number. So definition. A pure imaginary number is any number in the form bi. Okay? Now we have to be very, very careful because if I have two radicals, so let's say I have negative, the square root of negative 4 times the square root of negative 9. Okay? That is not equal to the square root of 36. Okay? You always have to, so this is not correct, you always have to simplify the imaginary part before you multiply. Okay, so in this one what we have to do is negative 1 times 4 and negative 1 times 9, which is I squared times 4 and I squared times 9. So that is 2i times 3i. So that's 2 times 3 times I, which is 6i squared. But I squared equals -1, so it's 6 times -1, or -6. So the correct answer here is -6. So remember, you always, always, always have to simplify the negative before you multiply. All right, so let's look at some examples. Example, I want to do the square root of -98, right? So to do that, I first divide it up into -1 times 98, but in 98 I'm looking for perfect squares, so 98 is 49 times 2. Then I want to change -1 to an imaginary number. And now the square root of 49 is 7. The square root of I squared is I. And 2 has to stay inside the radical. So the correct answer there is 7i square root 2. Next example. If I have square root of -9 times square root of -25. Remember, be careful here. You have to change it to imaginary numbers before you do the multiplying. So we're going to write this as -1 times 9 and -1 times 25. But -1 is I squared. So we're going to change it to imaginary numbers. Now, square root of 9 is 3. Square root of I squared is I. Square root of 25 is 5. Square root of I squared is I. Now 3 times 5 is 15. I times I is I squared. But that's really 15 times -1, or -15. So that is our correct answer. Alright. Now, imaginary numbers are kind of like radicals, in that we never leave an imaginary number in a denominator. So never leave imaginary numbers in the denominator. Okay? So for example, if I have 4 over 5i, I want to get rid of the I in the denominator. So I need to change it to an I squared. So I multiply top and bottom by I. So I get 4i over 5i squared, or 4i over 5 times -1, or 4i over -5. And we could write that as -4i over 5. So that's our final answer. Okay. Example 2. If I have 10 over the square root of -5, so that's really -1 times 5 in the denominator, but as an imaginary number, -1 is I squared. Okay, now remember that we cannot leave the I and we cannot leave the square root 5 in the denominator. So to get rid of the square root 5, we multiply top and bottom by square root 5. To get rid of the I, we multiply top and bottom by I. So we get 10i square root 5 on the top. On the bottom, we get 5i squared. But I squared is really, what is it? That's right, -1. And so we get 10 square root 5 over -5. and we can bring that negative to the numerator. And notice that 5 and 10 reduce, so we get negative 2 square root 5 as our final answer. Okay? All right, now we can also solve problems. So now we want to solve something like 3x squared plus 23 equals 5. Okay, so if I subtract 23 from both sides, I get 3x squared equals a negative 18, and divide both sides by 3, so I get x equals negative 6, or I'm sorry, x squared equals negative 6. Now, just like in previous sections, in order to solve that, we take the square root of both sides. But remember, it's plus or minus. Anytime you yourself put a radical in the problem, it's plus or minus. So the square root of x squared is x. And then we have plus or minus negative 1 times 6. But negative 1 is I squared. So we get x equals plus or minus I square root 6 as our solution. Okay? Example 2 with an equation. X squared plus 100 equals 0. So get the x squared by itself. Now I want to know what x is, not what x squared is, so I take the square root. But since I am taking the square root, it's plus or minus on the other side. And that's really negative 1 times 100. But in the imaginary numbers, negative 1 is I squared. So x equals plus or minus 10i. Square root of 100 is 10. Square root of I squared is I. And example number 3. 2z squared equals negative 128. So get the z squared by itself. So divide by 2. Get negative 64. Take the square root of both sides, remembering plus or minus. So we get z equals plus or minus the square root of negative 1 times 64. But in the imaginary numbers, negative 1 is I squared, times 64. So that's 8i. So our solution is plus or minus 8i. Alright, then we can also add imaginary numbers. So example, the directions might be simplify. Number 1, the square root of negative 20 plus the square root of negative 45. So we start out by simplifying each radical. So this is, well, let's do this. It's negative 1 times 20 plus negative 1 times 45. In the imaginary numbers, negative 1 is I squared. Then we are looking for squares. So we have 4 times 5 for 20. And for 45, we have 9 times 5. Okay, so then I can bring out a 2 and an I. And I can bring out a 3 and an I in the second one. Now, these are like radicals or like imaginary numbers, so I add the coefficients. So I add the 2 and the 3, so I get 5i square root 5. So it's just like terms. You add the number part in the front, but nothing else changes. Okay. We can also multiply imaginary numbers. So here's example 2. Let's say I have the square root of negative 20 times the square root of negative 45. So again, first of all, simplify inside the radicals. So we're going to change the negative to imaginary numbers. Then we're going to break it down. Let me make that better. Then we're going to simplify. Well, first I'm going to change the negative ones to imaginary numbers. Right? So this becomes 2i square root 5 times 3i square root 5. Now when we're multiplying, we multiply like thing times like thing. So 2 times 3 is 6. I times I is I squared. And square root 5 times square root 5 is 5. So 6 times 5 is 30i squared. But I squared is negative 1. So this is negative 30. Okay? And let's do one more addition one. I have example 3, the square root of negative 5 plus the square root of negative 80. Okay? First of all, change it so that you have a negative 1. Change the negative 1 to imaginary numbers. Okay, then we want to break down in the first square root, can't break down anything. But in the second square root, we get I squared times 16 times, what is that? No, it's not 16. Well, we have 16 times 5. Okay, and so then we bring out the I, and we bring out a 4 and an I. Then remember there's actually a 1 in front of this I, so I add the 1 and the 4, so that's 5i square root 5. Okay, notice when we're adding, all we do is add the coefficients. Nothing else changes. So that's our final answer.